Okay, let's have one more video to hopefully finish this section 5.3, and hopefully this has been in short pieces so it's not so overwhelming. Here we're going to talk about the medians of a triangle. Those come from a vertex. The median is a line segment whose endpoints are the vertex for one of the vertices of the triangle and the midpoint of the opposite side. So median means it's going from the vertex to the midpoint. And so I've given you a couple of different triangles here. It's not this one that's larger looks sort of like an isosceles, so it kind of looks like the median is a perpendicular line there, but it does not have to be. So I tried to draw a second triangle. I still didn't do a great job, where you can see that the median is not a perpendicular line. All it has to do is come from a vertex and go to the midpoint of the opposite side. So Theorem 5.8 says that the medians of a triangle are concurrent. Remember, that means we found out yesterday that the lines are all intersecting in one point. So the medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. So basically that means if I draw all the medians in, as I've tried to do in this triangle, they should intersect at a point where the smaller segment of the line, let me change colors, here is about 1/3 of what this other distance is, which would be, so this longer distance is 2/3 of the way of the whole line to this point. So the longer distance is from the vertex where the median is drawn to the point of concurrency. That's the longer part, the 2/3 part. All right, so in the drawing we have here, the length of DC, which is from here to here, is 2/3 the distance, the length of the whole line DJ. And from E to C, where I drew earlier, that is 2/3 the distance of the whole line EG. And then FC is 2/3 the length of the whole line FH. So those are for each different median in that triangle. The point of concurrency C, here where the medians intersect, is called the centroid. So we've seen circumcenters, we've heard of incenters, and now we've got centroid. There are a lot of different definitions in this, and I really hope you'll start studying, memorizing them now, and try to figure out how you can keep those straight. Okay, so example 3 has this triangle drawn, and it says that D is the centroid of triangle ABC. And they give us the measurement for DE, it's equal to 6, and they want us to find BE. So we have to think about our vocabulary. Centroid means the medians are intersecting, and so I know I can use Theorem 5.8, and that told me that from the vertex to the point of concurrency, that was 2/3 the length of the whole line. So that means from here to here, where I'm drawing the blue line in, that is 2/3 the length of the whole line BE. But the part that they gave me was DE, and that is measurement 6. So if the blue line that I've drawn in is 2/3 the length of the whole line, then that would leave DE as the 1/3 piece. So how could we find BE in that case? What do you think? Okay, so BE would be 1/3 of the whole line, and we know that DE is 2/3 of the whole line. So let's find the whole line. If DE is 1/3 of the whole line, because it was the smaller piece, then we know that DE is 6. So 6 has to be 1/3 of the whole length BE. Then if I want to get rid of that fraction 1/3, I would need to multiply both sides by 3. So 3 times 6 would equal 3 times 1/3 BE. And this will give me just 1 there. So 18 is what BE is going to be equal to. Okay, quick check 3 is still looking at the same triangle. They're asking us now to find BD, which is the length that I had colored in blue. So now that we know the whole length is 18, then we can say that BD is the one that's supposed to be 2/3 the length. So I'll have that BD, my B's aren't working out very well, is 2/3 times 18, which is going to equal, if I cancel, 3 goes into 18 6 times, that's going to equal 12. Now they also told me to check that BD plus DE equals BE. So we said BD was 12, and I knew that DE was 6. That equals 18, and that checks out because BE was equal to 18. All right, one more line that we're going to define in a triangle. An altitude in a triangle is the perpendicular segment from a vertex to a line containing the opposite side. So remember, the median went from a vertex and it had to go to the midpoint of the opposite side. Now the altitude has to be at a right angle. It does not have to go to the midpoint. So there are 3 different things that happen in the acute triangle. The first one, the altitude when it gets drawn ends up being drawn on the inside, like it's shown there. Remember, an acute triangle just means all the angles are acute. They're smaller than 90. In a right triangle, where we have one 90-degree angle, the altitude is one of the sides. So, and I've got it drawn in red there. And then when it's an obtuse triangle, so there's one obtuse angle, it turns out that the altitude ends up having to be drawn to the outside, where the bottom line of the triangle has been extended. So example 4, we're looking at, well, now we have to be able to distinguish, do I have an altitude, do I have a median, or is it neither one? So if I'm looking at the line ST in the triangle that's drawn, this line with blue, is it an altitude or a median or neither? Okay, so this time it's an altitude because it's drawn from a vertex to the opposite side and it's at a right angle. It's a perpendicular line. Okay, for quick check 4, is the line UW still in the same triangle, a median, an altitude, or neither? Okay, this time it's a median. And why would that be? Because the line is drawn from the vertex to the midpoint of the opposite side. So medians are always drawn to the midpoint. The last thing that has to do with altitudes in this section just tells us that if I drew an altitude for each vertex of the triangle, those would be concurrent, or they would intersect in one point, and at that point it would be called the orthocenter of the triangle. So we've heard of circumcenter, incenter, orthocenter, and centroid. 3 different things where the lines are intersecting or concurrent. And the last thing is that Theorem 5.9 tells us that the lines that contain the altitudes of a triangle are concurrent. It's basically telling us what we just read, except it's not naming it as the orthocenter. So you'll be using those sometimes as you look at triangles that are drawn. Okay, now you should be able to finish up your problems on section 5.3, and we'll go over any questions you have tomorrow.